Okay. And share my screen. No. Okay, so before I begin today's lesson, I just wanted to touch base to see if there were any issues with any of the questions or the homework that you would have an issue.
Yes, I just, when the class is over, can we go over 2 of the questions?
Which questions you're looking at?
This from the section 1, 57.
Yeah, but which page? Which page that is again?
Page 3, hold on. 362.
362. 362. Uh-huh.
57 and 63.
Let me get to page. Okay, so page 362, questions. Which questions?
57
57. Mm-hmm.
and 63.
And 63, 57, 57, and 63. Okay. All right. Anybody else? Miss Fernanda, Miss Nairn?
Yes, for me, it was exercise 7.1, and it was, I think 29, number 29.
7.129. Let me see. 7.1. Seven point one. That's page 380. Number 29. Okay. All right.
For me, it was number 57. I think that was called already.
Uh-huh.
And number 81.
On that same page 362.
Yes.
You said number 81. Okay. 362. Okay. All right, so let me look at those now then. That's 6.5. Okay. so hold on. All right, so I'm going to look at those a little later. We should be able to finish a little earlier today, depending on the pace, because we don't have as much slides as previous lessons. So we'll see how it goes, and then I could look at those questions. So for today, I hope you have your graph sheets, because we're going to be doing some more graphs. We're looking at 7.2 and 7.3, a portion of 7.3 from your text. And both of them have to do with graphing of equations, specifically linear equations. And when we say linear equations, basically we mean equations that when you graph them, you get a straight line. Okay, so both sections will be dealing with linear equation. One will be dealing with a single equation, and the other section will be dealing with multiple equations on the same graph. Okay, now we did some work with graphs last time. I didn't hear any of you mention anything about the graph questions. Let me see, 380. Let me see which it's 380 question. You said page number 29. What was that question about? 29. Okay, that was a one. Okay, that wasn't a straight line graph. So, all right. So what we're doing today shouldn't depend too much on the previous lesson. So we're gonna look at that, and then we look at those questions later. So we're starting at page 383. If you have the textbook, and on that page, they make reference to graphing using intercepts. Okay, so it says here that all equations in a particular form, which is ax plus by equals c, produce straight lines. You will notice that the power of x and the power of y is 1, even though it's not stated. We know once we don't see that power, it's the first power. And so any equation in that form will give you a straight line, and that's why they're called linear graphs, because they produce straight lines. So once you graph those equations, that's what you're going to end up with, as long as a and b are not both 0. Okay, and they're called linear equations in two variables, because the two variables we have are x and y. Now it says the x-intercept. So we might not have used this term recently, intercept. So when we talk about the intercept, the x-intercept is the point where the graph crosses the x-axis. So that's what the x-intercept means. And so it crosses the x-axis at that point, and at that point, y is 0. And the y-intercept, of course, then would be the point where the line crosses the y-axis, and at that point, x is 0. So we're going to look at an example, so it makes a little more sense when you see the example. So they give you this equation they want you to graph. And so one of the quickest way to graph an equation is to use the intercepts. So you're going to let x be 0 to find your y-intercept, and let y be 0 to find your x-intercept. And so in this case, you're asked to graph the equation 3x plus 2y equals 6 by finding the intercepts. There are other ways we can graph it. Last week, we actually formed a table of values, and we used the table of values to find a few values for x and y, and we used those to to draw the graph of an equation. So that method is actually we're using a table of values so a table of values you use to actually get some points to help you to plot the graph. But in this case, we're just using the intercepts. So the equation we had was 3x plus 2y equals 6. So your equation is here. 3x plus 2y equals 6. So you're going to find x-intercept first. So I said find x-intercept by letting y equal 0 and solving for x. So this is your equation. So if you let y be equal to 0, so that would be 2 times 0. So 3x plus 2 times 0 equals 6. Of course, 2 times 0 is 0. So it means that 3x is 6. So that means x then would be equal to 6 divided by 3, which is 2. Okay, so the line is going to pass through the x-axis at 2. And then to find the y-intercept, we're going to let x be 0. So if we let x be 0, that will help us to find where the line passes through the y-axis. So x is 0. So you say 3 times 0 gives you 0. So you end up eliminating this here because 3 times 0 is 0. So you end up with 2y equals 6. So if 2y is equal to 6, then y must be equal to 3. So the y-intercept is 3. So basically what they're saying with this is that the line is going to pass through the x-axis at 2 and the y-axis at 3. So you so you're going to draw your graph, and based on what we had here, x-axis at x equal 2, y equal 3. So x is equal to 2, so the line is going to pass through 2 on the x-axis. This is 2, 0. And then the line is going to pass through 3 on the y-axis. This is 0, 3. Because remember now, we we let x be 0 here, and in this case, we let y be 0. So this is 2, 0, and this is 0, 3. So the line passes through these 2 points. So you simply just place a ruler. After you mark these 2 points, you place a ruler along the 2 points and then extend the line outward on either side of the points to get the graph of that line. All right. So now you can always verify if you want to do a check. So they choose to use a check here. So they use 1. And if you go from 1 on the x up to the line and go across, that's just about 1.5. Okay. So you can verify your work by checking. So they choose to use 1. So you plug in 1 into the equation and see if you're going to get the 1.5 that they have on this at this point here. There are other points you could use. Let me see. There's a point here, like this one, 4 and -3. The line passes through 4, -3. You could use that as a checkpoint. Sometimes it's easier to use ones that's going to give you 2 whole numbers instead of fractions. There's another one that will give you 2 whole numbers. That's this one that says -2, and this I guess this is 6. -2, 6 would be another one that you could use as a checkpoint, but you don't necessarily have to use the whole number coordinates. You could use fractional ones as well. Once you plug it into the equation, it should work out. So, oh, they didn't do the actual calculation here. All right, but you could. So the equation we had was 3x plus 2y equals 6. 3x plus 2y equals 6. Now they use 1 and 1.5, but I'm going to try and use one of the whole number ones. So let me use 4 and -3. So at this point that I have here, let me highlight that. The point is x is 4 and y is -3. So we could, so that's your x and y. So if you put 3 times 4 plus 2 times -3, you should get 6. 3 4s are 12. And then 2 times -3 is negative plus -6. And 12 plus -6 does give you 6. So it means then our line is correct. Once we check 1 or 2 of the points to make sure it works with the equation, it means that we did correctly draw the line. Okay, so you could choose any point on the line, but like I said, it usually works out better if you could find a point that gives you two whole number coordinates to work instead of, in this case, where they have the fractional one. So I want you to try this coordinate here. This says, let's see, this is -2 and 6. -2 and 6. So your x coordinate is -2, your y coordinate is 6. Try that to see if it works out with this equation. I'll give you a minute to do that. Okay, so today Okay, so let's start with Miss Nairn. Tell me what you did with that one. Miss Nairn, you with us? Hello? Miss La Rochelle, are you with us? Hello?
Yeah.
Yeah, tell me what you did with the that point that I just asked you to check to see if it works.
-2 and is going up to 6. What you mean by what I did? Like how I plotted?
Okay, I didn't want to plot. What I wanted to do, I said to you that this point here, -2, 6 is on the line. That's one of the points on the line. So I wanted you to plug that -2, 6 into the equation, which is 3x plus 2y equals 6 to see if it worked. So basically what you would do, you would say 3 times -2
Plus 2 times 6.
plus 2 times 6 to see if that equals to 6. I put a question sign because we're not sure. So when you do that, what do you get?
I have -6 plus 12, which is equal to 6.
Okay, so it does work. Yeah, so that's all I wanted to do, to check it to see if it worked. Okay, so any point on this line that you choose, once you get the two coordinates for that point, once it's on the line, if you plug those two coordinates into the equation 3x plus 2y, you should it should work out to 6. So anywhere on the line, it would work out to 6. Okay, so to get a straight line, we only need 2 points. Once we could find 2 points, we can join those 2 points with a straight edge to form the line. So that's one of the things about the X and Y intercept. Those are 2 quick points you could find for any equation to help us to draw the graph of that equation. Now, when it comes to quadratic equations, because the quadratic equation is a curve, you can't just use 2 points, because 2 points will not give you a curve. You will need more than 2 points. Usually we look for between 5 to 7 at least. But with a straight line, 2 points is sufficient. And once you plot those 2 points, you could always just check any point on the line to see if that point works with the equation, just as a check. Because if you find a point on the line that doesn't work with the equation, it means that you probably did something wrong in your working out of the intercept. Any point you choose on the line should work with the equation. Okay, so that was the purpose of that exercise. So I give you this one here. I want you to find the x-intercept on the y-intercept. So remember now, to find the x-intercept, then you can let y equal 0 to help you find what the x-intercept is. And to find the y-intercept, you're going to let x be equal to 0 in the equation to find what the y-intercept is. And once you find those 2 intercepts, then you could plot them on the graph, join them together to get your line. So I'll give you a couple minutes to work out those 2, x and the y-intercept. Okay, Miss Nairn, are you with us?
Yes, I am.
Okay, so what you got for the x-intercept?
So for x-intercept, I got 3. I got 2x plus 0 equals 6. X equals 6 divided into 2.
Okay, so 2x plus 3 times 0 equals 6. So 2x is equal to 6. So x would be equal to 6 over 2. X equals 3. All right. And your y-intercept?
So my y-intercept, I got okay, so I guess it'll be 2 times 0 plus 3y is equal to 6. Y is equal to 6 divided into 3. Y is equal to 2.
Okay. So basically then, what we're going to do is find 3 on the x-axis, okay, which is right here. And we're going to find 2 on the y-axis, which is right there. And we're going to place a straight edge, ruler or something, and join those 2 points to get the graph of that equation. Okay. Once we are careful with our, oops. Okay, this thing keeps sliding. All right, so I'm off a little bit there, but that's the essence of it. We need something that doesn't slide too much on this thing. Yes. All right, but you should get the picture of how your graph should be. And so if you find any point on this graph, I'm going to choose this point here that says -2, 3. And we could check to see if it works. So if x is -2 and y is equal to 3, you substitute that in that equation, you're going to say 2 times -2 plus 3 times 3. Okay. So 2 times -2 is so -4, and 3 times 3 is 9. So something isn't too right with that. And I think probably because my line might be a little bit off. Okay, so let me double check here. That should be -2. That's +3. Okay, so that's one of the things now when we plot this, because I should be a little bit above, but because I'm using this screen, and when I try to put the ruler on it to plot the points, it keeps sliding. So it's not as accurate as it should be. Okay. But if it was drawn accurately, then I probably would have chosen another point. But this might have been a fractional. It doesn't necessarily go exactly through -2, +3. It's probably a fractional value. So it's off by, let me see, that's going to be actually 5. So it's off by 1. And as I say, because it wasn't an accurate drawing. Okay. So as you plot your points, you have to be careful to make sure that the ruler goes directly through it. But drawing on the screen was a little tricky for this particular one. But I guess you should get the point. Anywhere on the line that you choose, when you plug it into the equation, it should work out to give you the value of 6. Okay, so I'm going to move on to our next slide, which is the concept is on page 385. Page 385. Okay, so on 385, we mentioned something about slope. Okay, so you will notice that these lines that we have been looking at, they are drawn at a sort of angle. Okay, and we have a way of sort of trying to measure the angle at which the line falls or rises, as the case may be. And so the way that is measured is another way of finding what they call the steepness of the line or the slope. And so what we do, we look at the vertical change, which is the rise, compared to the horizontal change, which is the run. All right. And so we actually make up a ratio to show the difference between the rise and the run. So you see this line here. In order for us to determine what the slope is or the steepness of the line, we simply choose 2 points on the line. And we find out from those 2 points how far up you need. If you move up a certain number of points, how far across would you have to move to get to the second point? So this rise here, the number of places you have to move up is called your rise. The number of places you have to, and then the number of places you have to move across here is called your run. So the rise is actually showing you that change in your Y values. So your Y value on the Y axis was at this point. You move up a certain number of points. And then on the X axis, you started here and you move across to this location to get to the second point. So you started at a point on your Y, you move up, then you move across from the X to the second point. So it's really a change in your Y, which is your rise, over the change in your X, which is the run. Okay. And so that is how the slope of a line is calculated. The vertical change over the horizontal change. And vertical change is measured on the Y-axis. Horizontal change is measured on the X-axis. Now you'll see this note at the bottom. It says it's common notation. The letter M represents the slope of a line. So in this coordinate geometry, we use the letter M to represent the slope. And it says the letter M is used because it is the first letter of the French verb. It comes from this French word monter, which means to rise or to ascend. That's where the letter M is derived from for use in this case. Monter. I'm not sure if I'm pronouncing it right, but that's how it's spelled. Monter. Meaning to rise or to ascend. So let's look at an example here, page 385 of your book. So it says, find the slope of the line passing through each pair of points. So we have this point here from -3 to -3, 1, and -3, -1, and -2, 4. And the second point is -3, 4, and 2, -2. So we're going to look at the first one first. That's A. So the first point we have is -3, -1. So that's your X and Y, your first X, your first Y. And then the next point is -2, 4. So that's your second point. So that's why they call it x2, y2. So this 1 here and this 1 is just to indicate that this is your first point, -3, -1. And remember the coordinates are x, then y. So we have another x and y for the second set of coordinates. But this time we put the 2 there because this is now indicating your second coordinate. So in order to get the slope, you see we have this formula here. Your second point minus your first point for the y. Then your second point minus your first point for the x. Okay. And so that's the formula we're using here now. We're looking for the change in y over the change in x. So your second point was for y2, that's 4. Your first point for y was -1. So 4 minus -1 would be on top. And then the change in x, you start off with your second x point, which is 4, sorry, which is -2. And then the first x point, which is -3. So it's going to be -2, take away -3. So x2 is -2, x1 is -3. So -2 take away -3. And so when we work this out, 4 minus 1 gives you 5. That's like 4 plus 1. And then this is like -2 plus 3 gives you 1. So 5 divided by 1 is 5. So we could say then that the slope of this line is 5. And basically all that means is that for every 5 that you rise, you're going to have a run of 1. So you could see it here. So if you start at this point, which is -3, 1 right here, and the other point is -2, 4, -2, 4 right there. So those are 2 points that we plotted. And if you were to start from your first point and move up, you're going to go 1 square, 2 squares, 3 squares, 4 squares, 5 squares up, and then 1 square across to your right. So it's 5 units up and 1 unit across. So your rise is 5 and your run is 1. And so that's how we get that 5 over 1 to be equal to 5. So anywhere you go on this line, if you start from one point, go up to try to get across to another point, the slope should be the same. Okay? So the slope of a line doesn't change. Whichever 2 points you choose on the line to move from one to the next, the rise and the run will always work out to be the same. So sometimes you can choose other points, but because all of these seem to be, let me see, fractional, let me see if we could find another 2 points that you could use here. All right, so if you choose to use, I think this intersects right here. So if you wanted to, you could have started here and gone up 1, 2, 3, 4, 5, and then 1 across. That's still 5 over 1. Now you could have started here and gone all the way up to, let me see this, go all the way up and then across. In that case, you would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up, and then 1, 2. That's 2 across. So that still will give you 5 because you would divide 10 by 2. So you'd say m equals 10 over 2, which is equal to 5. Okay? So it still end up giving us 5, even if we choose some other points in this case. So wherever you choose 2 points on the line and do this kind of triangle to find the rise over run, you're going to get 5. So a straight line, the slope is the same whichever 2 points you choose. Now it says here the slope is for indicating that there is a vertical change, a rise of 5 units for each horizontal change. And what's this? A run of 1 unit. Okay, so for every 5 units you move vertically, your horizontal change is 1 unit across. Now it says the slope is positive and the line rises from left to right. So lines that run from left to right, like this one, once it runs from left to right, upward, it has a positive slope. Okay, so that's the indication of a positive slope. When it wants it from left to right, it's running upwards. Now, this study tip here is something that you need to be careful about. It says when computing slope, it makes no difference which point you call x1 and y1 and which you call x2 and y2. If you let x1 and y2 in this case be -2 and 4 and x2, y2 be -3 and 1, the slope is still 5. So you could choose instead of using this one as your first point, you could choose this one as your first, but note that the working will change somewhat, but it still gives you the same result. Okay. Now, I prefer to use the leftmost point as my start and the second point to the right as my second or ending point. But you don't have to. You could do the reverse, it's up to you, but just be consistent with whatever you're doing. So it says, however, you should not subtract in one order for the numerator and then subtract in the opposite order for the denominator. Okay, so just be careful about that. So if you use one set for the start, you have to use that same set for the end. You can't switch it around. So you see here they have 1 minus 4 and -3 minus -2. You have to be consistent. But if you change it around like this and put the -2 first, you change the order around, then it's going to affect the answer and this will end up being negative. And slopes that are negative do not rise, they actually fall. So if you have a negative slope, it will, as you move from left to right, it will go down. Lines with a positive slope go upward. So once you look at a line, you can determine right away whether the slope is going to be positive or negative, depending on how it's, whether it's falling or rising as you move from left to right. So let's look at the second example. So we did the first one just now. We're going to look at this other one. So in the second example, you are given those points again, -3, 4, and 2, -2. -3, 4, and 2, -2. So if you choose this to be the first, the other one to be the second, so y2 would be a -2, y1 would be 4, so -2 minus 4 gives you that, and then x2, okay, would be 2, x1 would be -3, so 2 minus -3. Okay, so 2 minus that gives you -6. That's like 2 plus 3 is 5. So that's a -6 over 5. So you're going to end up now with a negative gradient, -6 over 5 as your gradient. So once you see that negative, it means this line is actually going to be going down as you move from left to right. So if you start from left, move to the right, as you notice, this line is going downwards. Once it has a negative slope, it means the line is going down. And 6 over 5 means that for every 6 that you move vertically, So let's see, one, so you started here, 1, 2, 3, 4, 5, 6. And by the way, because this is a -6, you end up moving down instead of up. With the other one, you are moving up because you're at a positive, but with the negative slope, you're moving down. And then you move across 1, 2, 3, 4, 5. Okay. So the slope in this case is -6/5. It's going downwards. And wherever you measure on the line, you should get that same slope. Okay. So for every 6 that you move down, you're going to end up moving 5 units across. Now we can't, because the line, let me see, we don't have enough space to continue it further with 6 and 5. We could have checked another 2 points. Let me see, I think you could check right here. Let me see that. Is there another point where they intersect? Let me see if we, okay, I was trying to see if there was another point where this intersects, but it doesn't seem, no, that's a little off. That's not exactly off. Okay, so we don't have another point where it intersects as a whole, as 2 whole numbers. So we wouldn't be able to check another set of points. But if we did, then it would still work out to 6/5. You may get 12/10, which would simplify still to 6/5. Okay, so let's use what we just did to work out the slope of these two. And we want to plot them based on the information that we have. Okay, so we could either plot them and draw triangles, or we could use the formula. The formula says change in y over change in x. So that's y2 minus y1 over x2 minus x1. And we work out the slope. So we don't necessarily have to draw them. We could just use that equation, that formula, to work out the slope. So I want you to do the first one, give you a couple minutes, and then we look at it before we go to the second one. So work it out using the formula, and then we're going to look at the graph of it. Okay, we should be finished at least with the slope. Let me see who I have here now. Miss Fernanda. I heard from you
Yeah.
already.
Okay.
Okay. What you
For
do
A, I have -2 minus 4
Let me get my
divided by
pen.
-4 minus 3.
Hold on a minute. Okay, you
Okay.
said negative.
2
Uh-huh.
minus 4
Minus 4. Uh-huh.
divided
Over.
by, over -4 minus 3.
Mm-hmm.
And I
Oh, wait.
got,
Hold on. -4 minus 3.
yeah,
Okay. Okay. So that's equal now to
that's -1,
at
which
the
gives
top.
me,
The
pardon?
top. What you got at the top when you said
Oh, I got
-2
-6
-6. Uh-huh. At the bottom,
divided by -1.
-1. Okay.
It gives me 6.
Equal 6. Okay.
Mhm.
Make it into 6. All right. So that was who was that again? Miss Fernanda?
Yes.
Okay. All right, Miss La Rochelle. What you got for the next one?
For the next one, I have 5 minus -2
5 minus -2. Mm-hmm.
or -1 minus 4.
And then -1 minus 4. Okay.
And that's 7 over -5.
7 over -5, which is equal to -7 over 5. Okay. So even though you got oh, how should I put that now? Even though, okay, I shouldn't write it like this. Even though you get 7 over -5, we treat it as -7 over 5. The whole thing is negative because when we are going to work out the slope, this indicates that we are moving down 7 and across 5. So your horizontal movement is always basically positive, and the vertical is either going to be negative or positive. So if the vertical is positive, we're moving up. If the numerator is negative, we're going to be moving down. If the numerator is positive, we'll be moving up. So of course, this line will be sloping downwards, and this one will be sloping upwards because that's +6. And so you could always plot the two. So the first one is -3, 4. So -3, 4 is right here. And -4, -4, -2 is right here. Now let me see if I can find something. Slide because let's see. Okay, so that's basically how the line would look. And if you want to show how the slope is worked out, for that one, it's 6. That's 6 in fraction form is 6 over 1. So it means you're going to rise up 6. So if you start here, you move 1, 2, 3, 4, 5, 6, and then you move across 1. All right. So that's the triangle that you would form to show your how you work out your slope. Okay, so it's 6 up and 1 across. So every 6 up, 1 across you go, you should be able to find a point on this line. Okay, so that's the gradient straight across. Now in the next one, the points are 4, -2. You're gonna go to 4, -2, and then -1, 5, -1, 5. That's right here. And so you join those two. Okay, not exactly accurate, but all right. So, but this is how it look, and you notice that it's going downwards, and that's because we have a negative slope, and as a result, the line is going down as we move from left to right. Now, because it's negative, it means we're going to go down 7 and then across 5. So you start at this point that we've got here, 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5. Okay, so the triangle that we had formed to show the slope would be right here. So this is your how you'd work out your or show that your slope is 7/5, and because it's negative, we're going down and then across 5. Okay, so that's your 2 lines there that we were able to find the slope of. Now, the higher the slope, like this 6, of course, is the steeper the line. So if you had a line with a slope of 2, then you know it's not going to be as steep as this one. It's going to be a little more gentle in its slope. So a line with a slope of 12, of course, would be even more steep than this one is. So it would probably be somewhere up on this side here. So the higher it is, of course, is the steeper the line will be. And of course, the negative slopes are going downwards. All right, so let's move on. Okay, so on page 385, 386 of your book, you will see mention about the nature of slopes, the possibilities for the slope of a line. So you see, I think I just mentioned that, okay, if the gradient or the slope is greater than 0, that means it's a positive number. The line is going to rise from left to right, just like what you see here. So anytime the slope is a positive number, greater than 0 means it's positive. Anytime it's less than 0, that means it's going to be negative. Then the line is going to be falling as you move from left to right. So as you move from left to right, the line will fall. Now, lines that are horizontal, they have no slope. Okay, so the slope is equal to 0. Lines that are vertical, their slope is undefined. It's undefined. So you won't be able to work out a slope for a vertical line. There's no such thing as a slope for a vertical line. And then for a horizontal line, the slope is 0. Okay, so you'll see the explanation here. Example 2 illustrates that a line with a positive slope is rising from left to right, and a line with a negative slope is falling from left to right. By contrast, a horizontal line neither rises nor falls and has a slope of 0, which is what we show here. A vertical line has no horizontal change. So the change in x is equal to 0. And of course, you should know that we cannot divide by 0. So that's why this is said to be undefined, because you cannot divide by 0 because the change in x results in a 0 as your denominator, okay? You can divide 0, but you can't divide by 0. So for the horizontal, you might get 0/6. You can divide, 6 into 0 gives you 0. But if you get 6/0, there's no change in the x, then that's undefined. You get error if you try to divide by 0. So that's why you couldn't get a slope for a vertical line. Okay. So we're going to move on then. So the slope-intercept form of the equation of a non-vertical line with a slope of m and a y-intercept b is y equals mx plus b. So we could rewrite our equations in this form. And this form is called the slope-intercept form of the equation. So the equations that we looked at just now, they were not written in the slope-intercept form. Let me see what equation. Okay, so this equation that we looked at here, it was not written in the slope-intercept form. It's 2x plus 3y equals 6. To get it in the slope-intercept form, it should be written with y equals to some number, which was your slope times the x, plus some other number. So these are two examples of numbers written in the slope-intercept form. We could always rewrite the equation by rearranging it. So in this case, you have y equal 2x minus 4, and the slope is the coefficient of x, and this here is your y-intercept. So this is telling you that the line is going to pass through -4. Sometimes for certain types of equations, which we call functions, you could write it in this form. The function of x is equal to half x plus 2. So basically it's the same format, we're just changing this portion to represent a function. But the slope in this case is half, and the y-intercept is 2. So it means that it's going to pass through the y-intercept, the y-axis at 2. Now this slope here of 2, what that is telling us, because it's a positive 2, it's going to be rising, and for every 2 that you rise, you're going to move 1 across, because of course, 2 could be written as 2/1. So it's the rise over the run. So because it's positive, you're going to move 2 up and 1 across. And then it's going to pass through the point -4 on the y-axis. For this one, the slope is half, 1/2. So remember, the top number is the rise, the bottom number is the run. So you're going to rise 1 and move up across 2. It's still positive. Okay, it's positive. It doesn't say negative. So it's going to rise, and the line is going to pass through 2 on the y-axis. Okay, so the study tip here is showing writing the slope m as a fraction allows you to identify the rise, that's the fraction's numerator, and the run, the fraction's denominator. So this one is a fraction, so you could see it right away, but sometimes it's not given as a fraction. So like this 2, for example. So if you write it as a fraction, which will be 2/1, then you could see what the rise is and the run is right away. And so you should be able to use that to help you to graph the equation. All right, so we can use the slope-intercept form of an equation to graph the equation. So there are 3 steps given to you, which appears on page 387 of your book. And they explain to you how you could graph the equation using that format. So it says plot the point containing the y-intercept on the y-axis. Obtain the second point by using the slope. Write m as a fraction and use rise over run starting at the point containing the y-intercept to plot this point. Use a straight edge to draw a line through the 2 points, and then draw arrow heads at the end of the line to show that the line continues indefinitely in both directions. Now, I hadn't mentioned this part before, but you will see on the graphs that they have here, they have an arrowhead here and an arrowhead here. We normally do that to indicate that the line doesn't end just where we draw it. It continues on, but because of the limited space we have on the graph paper, we have to stop it, but just to indicate that it continues. Okay, so let's look at an example. So they ask you to graph the linear function y equals 2/3 x plus 2 by using the slope and y-intercept. So since the graph is given in the slope-intercept form, we can easily find the slope and y-intercept. So the coefficient of x is the slope, and then the constant here is the y-intercept. So what this is telling us for this equation is that the line is going to pass through 2 on the y-axis, and the slope of this line is 2/3. So we could use that to help us to actually draw this equation. So let's look at it. So again, y-intercept is 2. So the first thing we're going to do is go on the y-axis and find 2. So this is where 2 is on the y-axis. And now because the slope is 2/3, once we find that, that 2, you're going to now use the slope to help you to find the other point. So the other point would be, you'd have to rise 2 and run 3. So if you rise 2, you're going to go up, starting here, 1, 2, and then 1, 2, 3. So that's our second point. And now that we have the second point, we can now use a straight edge and join those 2 points to form the line. Now, depending on how much space you have in your graph, you could continue doing this rise and run several times to get more points. For example, if you wanted to, you could have gone start here again and go up 2, 1, 2, and then 1, 2, 3. And so you get another point. Okay. So if you could get more points, all the better, because it makes your line more accurate. And so this could be another point. And if you had more space, you could go up again, 1, 2, and then 3 across to get another point. But we didn't have any more space on the grid, so we just have to this is as far as we could go. All right, and if you want to, you could use a kind of reverse process, because you are going up 2, so you could go down 2 and move across 3, you get another point here, go down 2, move across 3, you get another point. So you could follow this pattern for several times and plot all the possible points, join them together, and you would get the graph of that line, y equals 2/3 x plus 2. So I trust you understand that process. So let's look at another one here. I want to try this checkpoint. So it tells you to graph the linear function y equals 3/5 x plus 1 using the slope and y-intercept. So give you a couple minutes to look at that, and then tell me, I'm going to call on you to tell me what you did. Okay, so let me see what do we have here. This nan, what's nan? Step away. Okay, Miss Fernanda. Miss Fernanda, you there? Miss La Rochelle?
That's all.
Okay. Tell me what you did.
I plot the y-intercept,
Mm-hmm. Which is
and I did, oh, that's on
the
the
y-intercept is 1. Okay.
y1,
So you're gonna do that. Okay, so that's 1. Mm-hmm.
and I did rise 3,
Okay, so go 1, 1, 2, 3. Uh-huh.
and then run 5.
Okay. 1, 2, 3, 4, 5. So you end up at 5, 4.
Yes.
Okay. Then once you do that,
You draw the line with the arrows.
okay. Okay. And then you put the arrows on the 2 end. Okay. So that would be the graph for that particular equation. Y equals 3/5 x plus 1. Okay. So your y-intercept is here, and then you rise 3 and run 5 to get another point, and then you join those points together to form the line. Okay. So far we have looked at, this would be the third method we looked at as to how to draw the equation of a line. You can calculate points like what we did last time by forming a table of values. And once we form a table of values and you work out the x and y values for a number of points, you plot those points, you get the graph. You can use the x and y intercept to do that as well. And then I'm not finished with that. I just need something to put it there. Yeah. You could plot the x and y intercepts, and then when the equation in this form here, the intercept slope form, then you plot the y-intercept and use the slope to work out where another point should be to draw the equation of the line. So those are 3 approaches we can use for drawing the graph of a linear function or linear equation. All right, so here now we have another example, but this time they don't exactly put the equation in the slope-intercept form. They put it in the form that we used when we started the lesson, where we were looking at calculating x and y intercept, okay? But even if they put it in this form, we can rewrite the equation into the slope-intercept form, okay? So this is what we got, 2x plus 5y equals 0. And we can rearrange the equation So you're gonna move the 2x. So it becomes 5y equals negative 2x, because you're moving it over to the right-hand side of the equation. 0 minus 2x is negative 2x. So y then would be equal to okay, y then is equal to negative 2 over 5, okay, x. But because we want this to be in the slope intercept form, we need to have this added to some value that we're going to plot on the y-axis, because we need the y-intercept. But because there was no y-intercept here, then we're going to end up using 0 as the, of course, adding 0 doesn't change the value of the equation. So the form that you're going to use, when you simplify the equation, this is what we got. Y equals minus 2x over 5. But in order for you to get the y-intercept, we have to add the 0 here. So it means that the line is going to pass through 0, and then you're going to move down 2 and across 5, because this is a negative slope. I mean, it's moving down. We go down 2 from 0 and across 5. And so let's look at the solution continued. So this is what we end up with when we change the equation around. So it says you're going to start at the y-intercept, which is 0, right there. And then to get the second point, you're going to move, because it's negative, you're going to move down 2, 1, 2, and then across 1, 2, 3, 4, 5. So you have the point at 0, 0, and then the other point right here, which is 5, negative 2. And then we can join those 2 points to form the graph of that equation. Okay, so we're going to do the same with this number 4. Rewrite the equation in the form, in the slope intercept form, then use that to draw the graph of that equation. Ms. Nairn, you with us?
Yeah.
Okay. All right. You want to tell me what you did with this one?
Okay, so I did 4y equal to 0 minus 3x. And then 4y over 4 is equal to negative 3x over 4. Y is equal to negative 3 over 4x. And y is equal to negative 3 over 4x plus 0.
Mm-hmm.
So then
Okay.
we'll start at 0 on the graph,
Okay.
and then we'll go down 3,
Mm-hmm.
and then we'll go move to the right 4.
Okay. So you're gonna stop at 4, -3.
Yes.
Okay. And then you plot, because it's a negative, it means then that you're going to it's going to be a, what's going on with this thing? Let's see. Okay. Okay. So your graph would look something like that. Okay. I'm trying to, who can see what we share here? Excuse me a minute there. This thing is starting up. Okay. Okay. Go back in again. Screen. No. There. Okay. All right. So not sure what's happening there. Okay. I'm gonna skip that. I think you get the point, but this device is kind of behaving strange. So I'm gonna move to the next slide. All right. So okay, so we also sometimes have to draw horizontal and vertical lines when we're graphing. And it says here the graph of y equal b is a horizontal line, and the y-intercept is b. And the graph of x equal a is a vertical line, and the x-intercept is a. So those are just the general forms for horizontal and vertical line. In this case, the b is representing a number, and here the a is representing some number. So whatever number b is here, it means that the line will pass through that number on the y-axis. Whatever number a is here, it means that the line will pass through that number on the x-axis. So we'll look at an example. So here it says, example 5, graph y equal -4 in the rectangular coordinate system. That just means to draw a graph of it using a graph sheet or graph paper. All right. So because y is equal to -4, if you were to draw up a table of values, all the values of y will be -4. That's what that basically means. Y is equal to -4. So any value you put for x, y will be -4. So you don't need to put more than 3 because you only really need two points. But you put 3, it's just a check. So they just chose to use -2, 0, and 3. And you'll notice that whatever value it is for x, y is -4 because that's what the equation says. Y is -4. So the 3 points we're going to use is -2, -4, 0, -4, 3, -4. Okay. So it says for all choices of x, y is a constant of -4. So you're going to go draw your graph. The 3 points we had was -2, 4, 0, -4, and 3, -4. And so the points are here. That's 2, -4. Sorry, -2, -4. This one is 0, -4. This one is 3, -4. Because it says y is equal to -4, we don't even need to do all of that. Once you understand that if you see a graph, an equation saying y is equal to some value, all it means is that you're going to draw a horizontal line passing through the y-axis at this number, which is in this case -4. So this is where -4 should be. It's between -3 and -5. So the graph of y equal -4 is going to pass through the y-axis at -4, and it's going to be a horizontal line. And likewise, we could do the same thing when it comes to x is equal to some value. In this case, they are told that x is equal to 2. So if you say x equal 2, no matter what value you give for x, for y, sorry, x will be equal to 2. That's what the equation says. X is 2. So x is always 2 here. So you could put any value for y, x is 2. And so with that being the case, the 3 points that they chose, you're going to get 2, -2, 2, 0, and 2, 3. So when you plot those 3, 2, 3, 2, 0, 2, -2, you get a vertical line that passes through 2 on the x-axis. So the graph of x equal 2, you don't necessarily need to do this table for it. Once you understand that any graph of an equation that says x equal to some value is going to give you a vertical line that's going to pass through that value on the x-axis. So if it was x equal 5, the line would pass through 5 on the x-axis, and it's going to be vertical. If it said x equal -3, the line is going to pass through -3 on the x-axis. It's going to be a vertical line. If it had said y equal 4, it would pass through the y-axis at 4, and it's going to be horizontal. Okay, so those would be two quick things you could use to remember how to plot a vertical and a horizontal line. Okay, so let's look at number 5. Let me see if you. Okay, so let me see, Miss La Rochelle. Look at that first one, checkpoint 5. Tell me what you understand that to mean. Miss La Rochelle, are you there?
Yes.
Okay, so it says y equal 3. You have to draw the graph of that. What you gonna do?
Draw a line at y equals 3 straight across.
So you're gonna draw a line.
Y
And here, yeah, so it's gonna pass through where?
just 3
3 where? Which axis? The x or the y axis?
axis.
Which axis?
Y.
The Y, okay, and is it going to be a horizontal or vertical line?
Vertical line.
Vertical, if it passes through 3 on the y-axis.
Sorry.
Through, I didn't hear you. Hello.
I didn't say anything else.
Okay, yeah, I'm asking you, it's going to pass through, you said it's going to pass through 3 on the y-axis, so I marked it right here. So is that going to be a vertical or horizontal line when you draw it?
A vertical,
Vertical means going up, down now.
horizontal.
It's going to be going this way, okay? So it's going to pass through the y-axis at 3, okay? And so if it passes through the y-axis at 3, then that's going to be a horizontal line. And so, oops, a little bit off anyway. That's that and that, okay? Now, of course, when you draw it, it's going to actually be on the line, but this device, it keeps sliding when I use this ruler because it's so slippery on a glass thing here, so it's not staying put. All right, but so it should be a little above where you see me draw that line, but this ruler keeps sliding. Okay, that was Miss La Rochelle. Miss Nairn, you still with us?
I'm here.
Okay, so the next one says x equal -2. How are we going to draw that line? What we're going to do? That
So we're
graph.
going to draw, we're going to go to 2 on the x axis.
Is that 2 or -2?
Oh, sorry, -2. Negative
Okay.
2 on the x axis.
Okay.
We're going to draw a vertical line.
Okay, so it's going to be a vertical line passing through 2. Let me see if this will stay put. Let me try. Okay. Oops, it went off again. Sorry. All right. So it should actually be on the line, this line here, but for some reason, this ruler keeps slipping. Okay. All right. So that would be your line for x equals -2. And this one would be for y equals 3. Of course, when you're drawing on paper, you shouldn't have the problem of slippage that I'm having with the screen, but the ruler keeps slipping on the screen because it's so, the ruler is plastic and the screen is glass. So it's not staying steady as I draw, but on paper, you shouldn't have that problem, okay? So that's your equation for the vertical and the horizontal, okay? Now, we have one application we could use for graphs. So this is a real world application that we can use. There are many applications, but here on page 390 of your book, they were trying to use it to show slope as a way of calculating rate of change. So here we have a graph, and graph is showing you the costs in billions of dollars of the largest federal entitlement programs. Of course, this would be the US. All right, so they have 3 programs mentioned there: Social Security, Medicare, and Medicaid. And so for Medicaid, they're saying 2007, it was 195 billion. In 2016, it was 392 billion. For Medicare, 2007 was 446, and 2016 was 909. And then for Social Security, 2007, the cost was 582 billion, and 2016 it was 970 billion. So we have 3 different lines on that graph showing you how the costs of these particular programs have changed between 2007 and 2016. So the question, it says here, in 2007, the US government faced the prospect of paying out more and more in Social Security, Medicare, and Medicaid benefits. The line graph in 7.25 show the cost of these entitlement programs in billions of dollars for 2007, with projections for years through 2016. Find the slope of the line segment representing Social Security, round to one decimal place. Describe what the slope represents. All right, so there are three slopes, but right now we're just concerned with the one for Social Security, which is the one at the top, the blue line. So the solution says you have to write X to represent a year and Y the cost in billions of dollars of Social Security in that year. The 2 points shown on the line segment for Social Security have the following coordinates. So you'll see Social Security in 2007, it was 582. In 2016, it was 970. So what they did, we look at the change in Y. So Y was 970 at the end, and at the beginning it was 582. So we put the 970 over minus the 582, and then the change in 2016 to 2007. So what they did a subtraction. 970 minus 582 gives you 388, and 2016 minus 2007 gives you 9. So to get the slope, then you're going to divide 388 by 9, which gives you, they wanted you to round it off to one decimal place, I think they said. Find the slope, round it, okay, to one decimal place. So once you divide it, you're going to get approximately 43.1. All right, so the slope is 43.1. So what that means basically then is that because that slope is 43.1, that's telling you that every year the rate of change is expected to go up by 43.1 billion. If we continue, if we follow this line, that's what it's suggesting, that on average, the increase of costs for Social Security is going up by 43.1 billion per year. That is the rate of change. So you can interpret slope as a example of a rate of change. So if you have an idea of how something is either increasing or decreasing, if you have a graph of the increase or decrease, you can use that graph to work out the slope. And based on what the slope is in the showing, it will tell you what the rate of change is per unit of time that we are measuring. In this case, we are measuring in years. So this slope is telling us that the price went up by 43 billion per year. Of course, if the slope was going downwards, it would mean that the price was actually falling. But because these are going up in all of them, there is an increase. Okay. So I want you to now look at this same graph, but we're going to look at this in terms of which one they want you to work out now. Medicare, which is the second one. I'll give you a couple minutes to look at that and see if you could figure out what was the slope for Medicare and what does that represent.
Hi, sorry, Mr. Allen. You said we're doing the one for Medicare?
Yes, yes.
Okay.
Mhm. Okay, Miss Fernanda, you want to tell me what you did so far?
Okay, I have 970 minus 446. Oh, no, that's wrong number. I was looking
That's
at the wrong thing.
perfect.
Sorry,
Sorry.
sorry.
Mm-hmm.
909
Mm-hmm.
minus 446
Mm-hmm.
is 463. And
Mm-hmm.
then I took 2016 minus 2007,
Mm-hmm. And that's equal to,
and that's equal to 9.
okay.
And then I have
Mm,
463 divided by 9, and that gave me 51.4.
okay. So your slope is 51.4. So what does that actually indicate? What is that?
Um,
Remember now, we're looking at slope as a rate of change.
oh, so that indicates that it went up.
It indicates it went up by how much?
True.
What's your what's your slope? The answer you got just now when you work out the slope, what's that?
51.4.
So
Which is
it's so it means then that the cost of Medicare is going up by $51.4 billion each year between 2007 and 2016. Okay, so this
Mhm.
answer you get is working out the increase per year because
Okay.
it was 463 over 9 years. So each year is going up by $51.4 billion. That's basically what they're saying. All right. Okay. So that's just one example of an application of slope. Uh, the type of answer you give will depend on the nature of the graph. So sometimes the graph may be in minutes, hours, seconds. Okay, so it all depends on what you, but in this case, we're looking at years. So this rate of change is per year. So it's going up by this amount every year. But if your unit was months or days or seconds or minutes or hours, then the rate would be reflective of that particular unit. Okay, you just have to read the question carefully and see what you're asked to do. And in this case, because the answer is positive, it also means that you are going up. And because the line is going up as you move from left to right, that also is an indication to you that it is increasing. Now, if the line was slanting downwards like this, then you know your answer would be negative, and it would also indicate that the actual item is falling in value over the period. But with none of these are actually falling, they're all increasing because they are pointing upwards. All right, so that's it for that. So that is the section 7.2. that we're going to be looking at. So we just have a portion of 7.3 to look at before we finish for today, and I look at those questions you asked me about. But in this section here, we are basically continuing the same thing, but what we are doing now is we are looking at two linear equations on the same coordinate plane. So it says here that two linear equations are called system of linear equations, or a linear system. Now, I don't know if you remember, some of you, some of you may remember in school when you did something called simultaneous equations. Simultaneous equations, okay? That's basically the same concept we're looking at here, but in a lot of the American books, they don't use the term simultaneous equations. They use the term system of linear equations, or a linear system. All right, so now it says here that a solution to a system of linear equations in two variables is an ordered pair that satisfies both equations. So if you have two equations like this, if you have a value that is supposed to be the solution, it should work for both of them. So this question is asking you to determine whether or not 1, 2 is the solution for this system. Of course, 1, 2 as a coordinate plane mean x is 1 and y is 2. So you could substitute 1 here and 2 there for both of these and see if you get the answer that's here. If you get the answer, then it means that it is the solution for both. So you'll see, okay, we have 2x minus 3y. X is 1, y is 2. So you're going to do 2 times 1 plus 3 times 2. 2 ones 2, 3 2 6. 2 minus 6 is negative 4. So it's true. They put a question sign there because we wasn't sure, but now we know it's so that's true. Then here in this one, 2x plus y equals 4. We know that x is 1, so that's 2 times 1. Y is 2, so we put the 2 in place of y. So 2 ones 2 plus 2 is 4, so that's true. So then it means then that the 1, 2 satisfies both equations. It makes each equation true. So thus the pair is a solution for the system. So that's the solution. So sometimes we have two equations and we are looking for a value that satisfies both. So when we find a value that satisfies both, we're actually looking for a solution for those equations. And the solution, and that's why in some books, especially the British books, they use simultaneous equation. It means that simultaneous, it means at the same time. This solution satisfies both of these equations at the same time. Okay, it satisfies both. So that's the purpose of this section, to show you how to work simultaneous equations. Now we could solve them graphically, or we could solve them using some other methods. We're not going to look at the other methods today. We'll look at them next class, substitution and so on. But for today, we're going to be looking at how you could graph them. But before we do the graphing of them, I want you to look at this checkpoint and see if you can work out whether or not this negative 4, 3 is a solution for both of these. So you're going to substitute negative 4 for x and 3 for y in both of them and see if you get a true statement for each. I'll give you a couple minutes to look at that. Oh, there we go. Okay, so there what you did.
Okay, so I did -4 plus 2 multiplied by 3 equals to 2, and that is correct.
Okay, that's -4 plus 6 equals 2. All right, yes, that's true.
And then the other one, I did -4 minus 2 multiplied by 3 equals to 6. That's incorrect. That's false.
Okay, that's -4 minus 6. Okay, that's not like that's not 6. So okay, so that means then that -4, 3 is not a solution of the system. Okay, it only works for one of them, but it doesn't work for both. So that's not the solution. All right, so we can find what would work for them. Let me see, x plus 2y equal 2, x minus 2y equals 6. Okay, so we're using that same example here now. We can find two values that would work for them. And like I said, there are different ways to do it. One method is to use the graph. Another method is to solve it algebraically by substitution, or one or two other methods, which we'll look at next class. But using the graphical method, it says for a system with one solution, the coordinates of the point of intersection of the lines is the system solution. So what they're saying is that if you graph the two of these, the point at which they intersect will give you the solution for these two. It will give you the two numbers that will work for both of them. So we can find the solution by graphing both x plus 2y equal 2 and x minus 2y equals 6 in the same graph. We'll use the intercepts to graph each. So the intercept, because of how they're set up, is quicker to just use the intercept, and then we could plot them quickly. So the x-intercept, so this is the first equation, x plus 2y equal 2. So if you're using the intercept method, you're going to let x equal 0, and you're going to let y equal 0. So to get the x-intercept, you're going to let y equal 0. So you're going to say x plus 2 times 0 equals 2. So x is equal to 2. All right. So the line is going to be passing through 2 on the x-axis. And then if you want the y-intercept, you're going to let x equal 2. So if you let x equal 2, that's going to be 0 plus 2y equal 2. So 2y equal 2. So y is equal to 1. So it's going to pass through 1 on the y-axis. Okay, so we're going to do the graph of this. So in the next slide, you will see the graph drawn, passing through 2, 0, and 0, 1. Let me see. Okay, so it's 2, 0, the blue line. Okay, 2, 0 is right here, and 0, 1 is right there. So it's going to be passing through 2, 0, and 0, 1. So you plot those two, join them together, and that will show you the graph for x plus 2y equal 2. So that was this one. Now for the next equation, it was x minus 2y equals 6. So again, the quickest way to get to plot this line is to use the intercepts. So x-intercept, you can let y equal 0. So if y equals 0, x minus 2 times 0 is 6, so x equals 6. And then to get the y-intercept, you're going to let x equal 0. So x is 0, so 0 minus 2y equals 6. So negative 2y equals 6, so y would be equal to 6 divided by negative 2, which is negative 3. So it's going to pass through 0, negative 3, and 6, 0. So it's going to pass through the x-axis at 6 and the y-axis at negative 3. So we're going to graph it, and they say they use the red line for that one. So the points we said were 6, 0. So it's going to be 6 on the x, -3 on the y, 6 on the x, which is right here, -3 on the y, which is right there. So that's the 2 points you plotted. And so they draw that as a red line. And so this would be the graph of the x minus 2y equals 6. Now you see the point where they intersect, it's right here. That's 4, -1. So that point where they intersect will provide you the solution for that would work for both of them. So if you were to substitute 4, -1 into each of those equations, you'll get a true result. So with we have we have it right here. The first one was x plus 2y equal 2. We said it's 4, -1. So you're going to put 4 in place of x and -1 in place of y. So 2 times -1 is -2. 4 plus -2 gives you 2. And then for this other one here, x minus 2y equals 6. You're going to put 4 in place of x, -1 in place of y. So that's 4 minus 2 times -1. 4 minus -2. That's 4 plus 2, which gives you 6. So it worked for both. Okay. So using the graph is one way to solve for the solution that would work for both equations. Okay. And so let's see what the study tip says. When solving inequations by graphing, neatly drawn graphs are essential for determining the points of intersection. And you see, when I was using the screen of my tablet to draw, because the ruler kept sliding, you couldn't get an accurate graph. But with the pencil and paper, you shouldn't have that much of a problem to draw the lines accurately. So if you are off slightly, the point of intersection might not be correct. So you have to be careful as you plot. So they suggest that you make sure to use graph paper, use a ruler or straight edge, and use a pencil with a sharp point. Okay, those help to ensure accuracy with your graphing. Okay, so that's one approach we can use to solve a system of linear equations to find a solution that works for both. So I want you to go ahead and try working this one out. See if you can get the intercepts for each of them, and then plot them and see what the point of intersection is for those two graphs, which would give you the solution. Okay, let me see. Miss Fernanda?
Yes. Okay.
Mhm,
So for the first one, I have 2x plus 3 times 0 equals 6.
mhm,
2x equals 6. X,
mhm,
then I canceled it out, 2x divided by 2 equals 6 divided by 2.
mhm.
X equals 4.
4?
I mean 3, sorry. 3,
Okay, all right.
yes. And then you want me to do the next one?
And then 2 times 0.
Plus y equals -2. Y equals -2.
Oh, hold on, hold on. But you have to find 2 points. You have to find 2 points for each line. So first you're gonna let you let y equal 0, then you're gonna let x equal 0. So 2x plus 2 times 0 plus 3y equals 6. So that's 0 plus 3y is equal to 6. So y would be equal to what?
Y will be equal to 2.
2. Okay. So for the first line, then it's going to pass through the x-axis at 3 and the y-axis at 2.
Yeah.
Okay. And so you're going to join those two to get that line. Let me see if I could get it. Okay. All right. And then now, for the second equation, you have Miss Fernanda, you still with us?
Oh, yes.
Mm-hmm. The second equation, 2x plus y equals -2. How we approach that? Miss Fernanda? Hello?
Oh, sorry. I thought my mic was off. Okay.
Mm-hmm.
So we're finding for x now. So we'll say 2 times, 2x.
Mm-hmm.
I'm confused. You have plus y? Oh, this is
Well,
second. Sorry.
that's the
Yes, that's
second
the one I was
equation,
looking
yeah.
up. So
Mm-hmm.
2x plus y equals -2.
Mm-hmm.
Then you'll say 2 times 0
Okay, you're gonna do that. Okay, 2 times
plus
0
3y equals -2.
plus y equals
Negative.
-2. Mm-hmm.
And then you have y equals -2.
Y equals -2. Okay. So you let x be 0, so now you're gonna let y be 0.
Okay, so now we'll say 2x equals -2.
Okay, 2x plus 0 equals -2.
Mhm.
So 2x is equal to -2. So x would be equal to,
Oh, you're waiting on me. -1.
-2 over 2, which is equal to -1. All right, so the second line going to pass through the y-axis at -2. Okay, and it's going to pass through the x-axis at that's that -1. So now we're going to join those two on the graph. Let's see now. Oops. All right. Doing those two carefully. Let's see if we could find the point of intersection. All right. Now it is okay. My thing's laid a bit, but it want to seem like it should be right here. I mean, it's not actually there based on what I have, but this is the closest whole number in points of intersection. Now, like I said, that's only the case because, like I said, this thing keeps sliding because you see I'm a little off the 2 here. So we're going to try that to see if it works, but this will be -2 and 3. So x, this is -2 and 3 is where the 2 seem to intersect. And so we could try that -2 and 3 with each equation to see if it works out. But the solution have to work for both of them. All right, so if we put 2 times -2 plus 3 times 3, you should get 3 times 3 is 9, 2 times -2. You're supposed to get 6. Okay, so it want to almost look like we are not correct with the line here, -2, 3. All right, so 2 times -2 is -4 plus 3 times 3 is 9. So we are off here by 1. That should actually give you 6, but this is actually giving me 5. And let's see what's happening with this other one. 2 times -2 plus 3 supposed to give you -2. So this is 2 times that is -4 plus 3 is giving us -1. So we're off 1 in both cases. So it simply means that the line is not accurate because we are off a bit here. So when you graph it on your graph sheet, you should be able to get a more accurate drawing than what I'm able to get on this screen. But whatever answer you get, it should work for both of the equations. I don't know if any of you were able to graph it. Anybody graphed it and got a more accurate response? Let me see. Any graphing? Let's see. Let's see. Miss Dan, Miss La Rochelle, Miss Fernanda, any of you draw the graph of it on a
No, I
sheet
didn't.
of paper?
Didn't, but I'm trying to do it now.
Okay.
I started to, but I actually have to leave now.
Mhm.
Yes,
Fernanda?
it's me.
So I need you to try it on the graph paper and see if you get the, okay. Let me check something. This is page, this is checkpoint 2, 7.3. Okay. According to the book, it should be -3, 4. So let me see, -3, 4. Okay. Y equal -2, x equal -1. All right. So we off a little bit because of the accuracy on the screen, but according to the book here, the answer should be -3, 4. So the intersection would be somewhere right here, okay? And we could always check that and see if you have 2 times -3 plus 3 times 4, that's -6, and plus 12, that will give you 6. All right, so that worked for that one. And then if we use 2 times -3, use that here, -3, and plus 4, that's -6 plus 4 gives you -2, right? So the answer is actually -3, 4. And that's one of the disadvantage of using the graph to solve these types of equations. So next week, we'll be looking at a more accurate approach, which would be to use algebraic methods, because the graph all depends on how accurate your grid is and how you're able to get those straight lines. And the fact of the matter is that 2 points close together are not good measures. And that's why one of the reasons why the intercept method is not always the best method to draw your graph. It's a good way to kind of get a quick sketch of to see what a graph look like. But if you only use 2 points which are close to each other, you're not going to get a very accurate representation of the line if you have to extend it out, especially if you're using a surface where you won't be able to get the accurate drawing of the line. So the graphical method is not the best method for solving. It is a method that could give you a rough idea of what your result should be and to show you some trends. But the more accurate method to solve a system of linear equations is to solve it algebraically. So if you try it on your graph, you should be getting the point of intersection to be -3, 4. But like I said, if it's not accurate, you can be off to a point where your answer that you get will not satisfy both equations. So you have to be very careful with the plotting of the points, but it should be -3, 4 as the solution for that one. Okay, but it was kind of difficult to draw on the screen, so that's partly one of the reasons why we didn't get the exact answer for the but even if you use the graph paper, you with these 2 points being so close to each other, there's a possibility that you could be off a bit in your line when you extend it further. And that's why 2 points are not usually sufficient to get your accurate lines. It's good to have at least 3 to 4 points on the line too, and they shouldn't be too close to each other. All right, so that's it for that. I think I already sent the presentation to you. So these are the questions for your homework. Okay, the questions are here. And okay, so you have 7.2 and a portion of 7.3. And then the answers are here. And now you're supposed to also be doing a test. I'm going to send that to you by Monday, a quiz or test based on what we did between what you did for test 3 and now. So I'll send that to you. You could scan it, answer on the sheet, scan it back to me before the date I'm going to let you know of, so that I could mark it in time for next week, Saturday. We have class next week, Saturday, which would be the 16th. And then, let me see, after the 16th, now the 23rd, you're going to have another midterm, the second midterm. And so you'll be going to the BIFS office to do that on the 23rd. So next week, Saturday is regular class, and then the 23rd is the second midterm, and then the 30th of April will be the last class. Okay, so I'll send you the quiz number 4 by Monday for you to do. Now, before we finish, I want to see if I could look at those questions you asked about. So the first one is, let me see, this one that says x squared plus 4x equals 6. Okay, so before you can solve the quadratic, you have to put it in the form x squared plus 4x minus 6 equals 0. And in this case, x equal 1. Sorry, not x, sorry. A equals 1, B equals 4, and C equals -6. All right, and so our formula then would be x equals minus b plus or minus square root of b squared minus 4ac all over 2a. And so minus b would be minus 4 plus or minus the square root of 4 squared minus 4 times 1 times minus 6 all over 2 times 1. Okay, so that's minus 4 plus or minus square root of 16, and 4 times 1 is -4 times, that's plus 4, 6 is 24 over 2. That's minus 4 plus or minus, okay, square root of 40 over 2. Now, I think where you may have had a challenge is when it comes to square root of 40. Now, square root of 44 is a perfect square, so you could break that to minus 4 plus or minus the square root of 4 times 10 over 2. 4 is a perfect square, so you could break that to minus 4 plus or minus square root of 4 times square root of 10 over 2. Square root of 4 is 2, so minus, so put a minus here, plus or minus 4 plus or minus 2 square root 10 over 2. Okay, and now that we have 2 in front of 2 times that, and we have 4, this 2 can divide this 4, and this 2 can divide this 2. So we could simplify that to minus 2, 2 into 2 into minus 4 is minus 2. 2 into 2 is 1. So that's going to actually be plus or minus square root 10. Okay, so your two answers would be minus 2 plus square root 10 or minus 2 minus square root 10. And so those are your two possibilities for that one.
When you simplified it with the 2, you did 2 and a 2, which is 1.
Mhm.
It would not cancel out the bottom 2. How come you were able to do the 4 also?
Because this well, you can't just cancel one term only. You have to cancel both.
Okay.
That's why I think that's one of the study tips that was on the slide that you did for the last class. When you're canceling here, you have to cancel for both of them to simplify. You can't just cancel on one. So if I say 2 into 2, 1, and 2 into this 1, I also have to do something up here. You can't just do this portion by itself. Okay. So
Okay.
if for example, if this was a 5 and I couldn't divide the 5 by 2, then I couldn't do any canceling up here. I just have to leave it as -5 plus or minus 2 square root 10 over
So
2.
when you cancel out the 2 in front of the square root 10, that doesn't drop the square root sign?
No,
Okay.
no, that's saying 2 times square root 10. 2 times square root 10, so you cancel that out, you're going to just left with square root 10 by itself,
Okay.
right? Okay. And you can't cancel out this 10 because that's square root 10. That's not 10 by itself. So it still have to remain a square root 10. Let's see. Okay, so that's it there. Okay, so that was number 57. So let me see now, number 63. So that one was 6x squared minus 5x minus 6 equals 0. So in that case, we're going to rewrite. So A is equal to 6, B equals -5, C equals -6. So based on this equation, we have x equals minus b plus or minus square roots of b squared minus 4ac all over 2a. So we're going to now say x equals minus 5 minus of -5 plus or minus the square root of b squared, so that's -5 squared minus 4 times a is 6 times -6 all over 2 times 6. Okay, so it's going to be equal to negative of -5 would be just 5 plus or minus square root -5 squared would be 25, and then 4 times 6 times 6. Okay, 4 6s are 24, and then we're going to multiply 6 times 24. 6 times 2, 4 equals, so that's 144, and that's going to be a positive 144 because you have two negative signs here, so that's plus 144, and that's going to be over 12. Well, yeah, 2 6s are 12. Okay, So then that's going to be equal to 5 plus or minus 125 plus 144 is the square root of, that's what, 169 over 12. Okay, so that's equal to 5 plus or minus the square root of 169. You should be able to work that out. I think that's 13. 169 square root is 13. So that's 5 plus or minus 13
I have a question, Miss Allen.
over 12, yes.
The square root of 5, it changed from negative because it was 12 square root 8.
Where you referring to now? Up here?
But yeah, I see you just have a positive 25.
Yeah, because we -5 times -5, negative times negative is positive.
Oh, okay, okay.
Mhm. All right, so anytime you square in a negative number, your result will be positive. Okay, so this is 5 plus or minus 13 over 12. So that means your answer is either going to be 5 plus 13 over 12 or 5 minus 13 over 12. So 5 plus 13 that's 18 over 12. And 5 minus 13. What is 5 minus 13? That's -8. -8 over 12. Now, both of these could be reduced to lower terms. 6 go into this, 6 into that is 3, 6 into that is 2. So that's equal to 3 over 2, or 4 into that is 2, 4 into that is 3, 2, or minus 2 over 3. Yeah, so that's the answer for that one. 3 over 2 or -2 over 3. All right, so once this number here is a perfect square, you can go ahead and find the square root. But if it's not a perfect square, then you'd have to do like what we did with the previous example, leave it in radical form and try to simplify it as best as you can. Okay, but this, okay, what's going on? Okay, so this one, okay. So now the next one was a word problem. Okay, so that word problem, let's see what it said. That was page, what's that again? Page 380. Okay, and this number 80. 7.1. Number. All right, let's see. Page 380, 7.1, number 29. Oh, number 81. Okay, that one says, I see the question. Trying to locate the question y'all asked there. I don't see. Let's see, 7.1, 6.5. Oh, 6.5, number 81. Okay, let's see. That's page. Okay, trying to repair that question. 6.5. 6.5, number 81. Okay, that was a word problem. So it says when the sum of 6 and twice a positive number is subtracted from the square of a number, 0 results. Is that the question? I don't remember if someone asked this question. Number
Yes, that's
81.
it.
Okay, all right. So for that one, they're saying to you when the sum of 6 and twice a positive number is subtracted from the square of the number, 0 results. So you're going to subtract from the square of the number. So the number is x, so the x squared minus the sum. That means you're going to add these two numbers together. So you're going to subtract from the sum of 6 and twice the number. So 6 plus twice the number, you're going to get 0. All right, so let's look at that again. When the sum of 6 and twice a positive number is subtracted from the square of the number. Okay, 0 results. Okay, so that would be your equation that you would have to start off with. So you're going to subtract from the square of the number, the sum of the 6 and twice the number. So first now we have to rewrite this without the brackets in the standard form for the quadratic equation. So you would say x squared minus 6 minus 2x equals 0. So you could say x squared minus 2x minus 6 equals 0. Okay. So in this case then, a equals 1, b equals -2, and c equals -6. Okay, so you're going to substitute that into the formula. So you're going to have x equals -b plus or minus square root of b squared minus 4ac all over 2a. So minus b, so that's going to be minus -2 plus or minus the square root. B squared would be -2 squared minus 4 times 1 times -6. And all of that should be over 2 times 1. So minus 2, that's like a +2 plus or minus square root of 4, and 4 times that gives you, that's 24. That's a +24, that's +24. And that's going to be over 2. Okay. So 2 plus or minus the square root of 28. Okay, that gives you 28. And that's going to be over 2. Oh, yeah. Okay. So now you don't have a perfect square here. So what you'll have to do is to see if you could simplify it in radical form. Now you know that 4 times 7 gives you 28. So you could break this to 4 times 7 because 4 is a perfect square. So it would be 2 plus or minus square root of 4 times 7 over 2, which you could break down to 2 plus or minus square root of 4 times the square root of 7 over 2. Okay. Now we know that the square root of 4 is 2. So that would be 2 plus or minus 2 square root 7 over 2. Now, the same thing like what we do the other one. You have a 2 here and you have a 2 in front of this. So you could use this 2 to cancel both of them. So that would give you 2 into 2, 1. That's 1 plus or minus square root of 7. Okay, so this 2 gets canceled out. 2 cancel out there, 22, 1. So that's 1 plus or minus. Now, they want the positive result. So the one of these answers would be negative because the square root of 7 is going to be more than 1. The square root of 7 is going to be more than 1. So if you say 1 minus something that's more than 1, you can get a negative result. So the only answer that would work for us. So the answer is either 1 plus square root 7 or 1 minus square root 7. So they ask you for the positive number that would give you that. So it can't be this one because if you take away what the square root of 7 from 1, you're going to get a negative result. Now, if they didn't specifically say, give me the positive answer that would give the result, then I would have to put both of them. But because the question asks you for the find the number, it says twice a positive number. So it would have to be just this one. Okay, but if they didn't specify the positive result, then you would have to give both. Okay, so that's the answer for question number 81, I think that is, yeah. All right, then the next one, somebody had a question about the graph, page 20, that's 7.1, number 29. Let me see, 29, 7.1. I think that was the graph for y equals x to the third power. No, do I have space for that? Let me see if I can find what I could do that one. Okay, I'll probably use this space here. Okay, so they want you to draw the graph of y equals x to the third power, and you want to use points from -3 to +3. So x would be -3, -2, -1, 0, 1, 2, and 3. So when you cube this, that means you're going to multiply it by itself 3 times. So y, if x is equal to -3, y would be -3 times -3 times -3 would be a -27. Okay. 2 times -2 times -2 times -2 would give you a -8. Yeah, okay. -1 times -1 times -1 would give you a -1. 0 times 0 times 0 would give you 0. 1 times 1 times 1 would give you 1. 2 times 2 times 2 would give you 8. And 3 times 3 times 3 would give you 27. So those are the points you would need to plot. Now let me see if I could change the color of this thing. Okay, so if we plot those points, so we see -3 and -20. Now the problem with this, I don't have enough space on this graph to do -3, negative. So I'm going to do -2, -8. So go -2. -2, -8 would be right here. Okay. -1, -1 would be right here. 0, 0 is here. 1, 1 is here. 2, 8 would be up here. All right, so I don't have space for this one or for this one. Okay, so we'd have to either have a bigger graph or change the scale. But based on what we have so far, I could show you that the graph should look something sort of like this. Okay, that would be how the graph would look for that. So that's just a part of it. But if you had a bigger graph, it would extend further down and further above. But that's the general shape of it. If you look in your book for your slide for the answers, I think the graph have this kind of shape here, but our graph sheet doesn't have enough space to go up to 27, but you should get the picture of how it should look. Okay, so that's it for that. All right, any other questions regarding the what I just looked at? You think you got the picture, Miss? Who do I have here? Miss Rochelle, Miss Nairn?
No question.
Okay, all right. So, all right. So that's it for now. I will send you the fourth. That will be a last quiz. Sometime either tomorrow or Monday, and then we're going to be looking at some more graphs next class. So you need to get some more of the graph sheets for that. And we will be looking also at other ways to solve the system of linear equations, because the graphical method is not the best way. So we're going to be looking at some other methods, which will be in 7.3. And then we'll start looking at the graph of quadratic equations, which will give you a curve. So you will need a graph paper for that. Okay. So if there are no other questions, I wish you a good week, and we hopefully will meet again next week. Even though next week is the holiday weekend, we still have class. Okay. So see you then. Bye-bye.
Okay.
Okay.